Hello again. In this video, we're going to look at the following two examples using double angle identities. So example 1, find function values of 2 theta given information about theta. So we know that cosine of theta is 3/5 and sine of theta is negative. So we want to look for sine of 2 theta. The identity for sine of 2 theta is 2 sine of theta cosine of theta. So we already know cosine of theta, so all we need to do is find the sine of theta. And there's several ways of finding sine of theta. You can find sine of theta using identities, like the Pythagorean identity, for example, or you could make a picture. So I'm going to go ahead and just make a picture. So we know that sine of theta is negative, so it's either in the third or fourth quadrant. But cosine of theta is positive. So I'm going to put it in the fourth quadrant. It's the only quadrant that makes sense because cosine of theta has to be positive. Cosine of theta being positive is only in quadrant 1 because the x is positive, or 4. But then the sine of theta being negative makes it in 4. And I'm going to make this a y, and I'm going to go ahead and find that value of y. So we know 9 plus y squared is 25, or y squared equals 25 minus 9, which is 16. So y is usually plus or minus 4, but I know it's negative, so I'm going to make it negative 4. So that would be the y. So now that gives us that sine of theta is the y over the r, so it is the negative 4 over 5. So we could just now plug this in to sine of theta, we just found is negative 4/5. Cosine of theta, we were given that it was 3/5. And if you just put this over 1, the answer would negative 24. 8 times 3 over 25 would be the answer for sine of 2 theta. So now let's try cosine of 2 theta. There are 3 different versions of cosine 2 theta. Cosine squared theta minus sine squared theta, that is the one that I usually memorize. But then if you plug in 1 minus sine squared for cosine squared, you get the second one. And we saw this in the last video. And if you plug in 1 minus cosine squared for the first one, you get the third one. I'm going to go ahead and use just the third one. Any 3 would be fine because you know both sine and cosine. But you can see here you didn't need to find sine. If you just use the last one, you can just plug in a 3/5 there because that was given. And then that would be the answer. So let's just go ahead and figure that out. That would be 2 over 1 times 9/25 minus 1. So I'll make it minus 25 over 25 because that's minus 1. So that would be 18 over 25. And let's just make this minus 25 over 25, which is negative 7 over 25. That would be the answer to the second one. The third one, tangent. The identity for tangent of 2 theta is 2 tangent of theta over 1 minus tangent squared of theta. So we first need to find tangent of theta. So in this case, we still need to draw a picture. And you can see from our picture that tangent of theta we know is y over x, which is negative 4 over 3. So if I just plug that in there, 2 negative 4 over 3 all over 1 minus negative 4 over 3 squared. What is that? That is equal to, put this over 1, negative 8 over 3 all over 1 minus, because that's outside the squared, positive 16, because negative 4 squared is 16 over 9. So what I'm going to do is I'm going to get rid of the double fraction. So I'm going to go ahead and multiply both top and bottom by 9. The top by 9 and the bottom by 9 to get this would cancel, get a 3, so that would give me a negative 24 in the numerator. The denominator, distributing that would be 9 minus 16, which is negative 24 over negative 7, or 2 negatives make a positive. So there is tangent of 2 theta. And that would be how you find all 3. So now let's try example 2. Find the function values of theta given information about 2 theta. So we want to find now all six trigonometric functions the other way around if you're given that cosine of 2 theta is 4/5. And they know that theta is going to be between 90 and 180 degrees. If theta is between 90 and 180 degrees, we know that theta is in the second quadrant, because here's 90 degrees and here's 180 degrees. So we know that theta is in the second quadrant. And I'm going to write down one of these versions here. I'm going to just start with just cosine. Cosine of 2 theta, or sine, is equal to 2 cosine squared theta minus 1. Because we can actually solve for cosine theta. I can add 1 to both sides. And then I could divide by 2. So you can see here, putting cosine squared theta on the left, we can say that cosine squared theta is cosine of 2 theta plus 1 over 2. This is another identity, an alternate form of cosine squared of theta. So we're going to have here that we know that this is 4/5 plus 1 divided by 2. And again, you can figure this out in many ways, but I'm going to go ahead and just multiply the top and bottom by 5 to get rid of the double fraction again. And we're going to get, using the distributive property, 4 plus 5 over 10. So you're going to get 9/10. So we know in our picture, if I draw this down, we know that cosine, I didn't figure out cosine yet. Cosine of theta, we have to take the square root of both sides, is going to be the square root of 9 over 10. And it is going to be negative because it's in that second quadrant, which is, by the way, negative 3 over the square root of 10. And I'm going to leave it like that and not rationalize it yet, because I'm going to make this a negative 3 along the x and the square root of 10. I can make a picture and find all my other values. You could find sine by using the second version that I have on example 1. And then you could find tangent as well by using another identity. But I'm just going to go ahead and make a picture now. So now we have here that, call this y, x squared plus y squared equals r squared. So we know that negative 3 squared plus y squared equals square root of 10 squared, or 9 plus y squared equals 10, or y squared equals 1. So we know that y is 1. Put that there, 1. It's a positive 1 because, again, it's in the second quadrant and the y is positive. So then we can easily find sine of theta, which we know is 1 over this y over the r, which we know is 1 over the square root of 10. And then I can rationalize now, because now I'm done drawing my picture. I think it's just easier to draw the picture when you don't rationalize. And then this one we know is negative 3 square root of 10 over 10. So there's cosine, that's what I started with. There's sine. Tangent of theta. We could use an identity again, but I could just say it's the y over x in our picture. So it's going to be 1 over -3, or -1/3. And then secant of theta, we know is a flip of cosine, so that's square root of 10 over -3, or negative square root of 10 over 3. Cosecant of theta is the opposite 1 over sine, and so that would just be square root of 10 over 1. And finally, cotangent of theta is the flip reciprocal of tangent, so this is just -3. And there is our 6 trigonometric functions if cosine of 2 theta is 4/5. I hope that helps.